Hello everyone. In today's experiment, we are dealing with the design and implementation of low-pass IIR filter uh, and also high-pass IIR filter using Butterworth filter. Okay. Um, First, let's see what do you mean by this IIR filter. IIR filters is nothing but it is called a infinite impulse response filter. It is basically a digital filter which is used in signal processing that has an impulse response lasting indefinitely. This is because the filter's output depends not only on the current and previous input values but also on the previous output values. Because of this mechanism, we call it as a IR filter. And when we come to the what are the key features of this IR filters is it is having a feedback loop. IR filters use this feedback that is because the part of the output is fed back into the input. This creates a recursive relationship allowing the filter to remember previous outputs leading to an infinite response. And also IR filters often require fewer coefficients uh, to achieve a desired frequency response compared to FIR filters that makes them computationally efficient. Unlike FIR filters, which is basically having a finite impulse response, that is the filter output eventually becomes zero after a certain number of time steps. The impulse response of IR filter does not die out completely, and theoretically it continues indefinitely. IR filters that must be carefully designed to ensure that they are stable because of the feedback mechanism, otherwise it will oscillate. And these IR filters are often designed using analog filter prototypes like Butterworth filter, Chebyshev filter, elliptic filters, and then transformed into their digital equivalents using techniques like the bilinear transform. The combination of feedback and feed forward components makes the IIR filters powerful for various applications. This is regarding the IIR filter, and today we are implementing this IIR filter using Butterworth filter. So let's see what do you mean by this Butterworth filter. It is basically a filter that is designed to have a frequency response that is as flat as possible in the passband. Uh, it is widely used in electronic and signal processing to remove unwanted components, that is like noise from a signal, while maintaining a smooth transition between the passband and stop band. Okay. And when it comes to the characteristics of Butterworth filter, the Butterworth filter does not have ripples in the passband or stop band, meaning it has a smooth flat response up to the cutoff frequency. And we use the order of the filter. Highest the order of the filter, the sharper the cutoff between the stop band and pass band. And it's also used in variety of applications like in audio processing, data smoothing, communication systems. Okay, in order to, and also in various domains where clean signal transmission is critical. Now we'll get into the design of this IR filter. For that, let's see what are the parameters we required in order to design this IR filter. Okay, as I explained for FIR filter, in order to design IR filter, we require three parameters. One is the cutoff frequency, second one is the sampling frequency, and third one is again the order of the filter. Okay, and this is the syntax we use to design an IIR filter, where IIR indicates it is an IIR filter and the argument n within this that indicates the filter order. F type indicates the filter type. What type of filter are we using? Are we using a low pass filter, high pass filter, band pass filter, and a stop band filter? Okay, and F design is basically a what kind of analog filter design we are using. Like as I said earlier, are we using a Butterworth filter, Chebyshev filter, or elliptic filter, like that? Okay. And also FRQ is nothing but it is a cutoff frequency, and this last parameter, this delta, this we basically use this during the Chebyshev analog filter design. If you are using an Chebyshev filter approximation, then we use this delta value, but for your syllabus you are not having a Chebyshev filter, we are dealing with Butterworth filter. So since we are not dealing with Chebyshev, we make this argument as 0. Okay. This is what the design parameters we required, and also this is the syntax of it. And next, see the problem statement now. Here, what is the problem we are taken is we need to design a third order low pass Butterworth filter with a cutoff frequency of 1000 Hertz and a sampling frequency of 8000 Hertz. Here n is nothing but a 3. Okay, that is the order of the Butterworth filter. Now let's go to the program. Okay, this is the program, okay, where we have define the cutoff frequency, which is given in the question as 1000, and the sampling frequency 8000. As I told earlier in the previous experiment also, whenever we are using a cutoff frequency, we need to use a normalized frequency. For that, I have divided the cutoff frequency by sampling frequency, and this is the syntax of IIR filter, where we have defined a order 3 and a low pass filter, and also the unlock filter is Butterworth filter, and this is the normalized cutoff frequency, and this parameter we basically use it for Chebyshev. Since we are not using it, we made it as 0 0. Okay, that will give you the frequency response of the IIR filter. Okay, and this is the magnitude of frequency response. Okay, and again this is the, we are plotting the figure of that one, and where y-axis indicates the magnitude of the frequency response, and x-axis is nothing but it is in a frequency, and this is the label. X-axis is frequency, this is the amplitude y-axis, and the title we are given is IIR high pass, sorry, this is supposed to be low pass filter because we are designing it for low pass filter. Fine. Now let's see what's the output will be. See, this is a IIR low pass filter for this particular design. Okay, it is passing up to certain frequency, and later on it is 1808. Similarly, if you want to implement the same thing for the high pass filter, it is given as, instead of LP we are changed into HP, and let me just change this also. Okay, then we'll run. This is a IIR high pass filter. Again, here also you can change the order of the filter. Let me change it to 5. Okay, see, that shows how sharp it is. Higher the order of the filter, the sharper is the pass band and stop band transition. Okay, and you can also change the cutoff frequency, you can change the sampling frequency, and you can try out for different possibilities of Butterworth filter. Okay, thank you.